Good evening and welcome to the Oliveboard platform. My name is Maruch Sharma, your logical reasoning expert, and we are here today to start and finish this new topic, new pattern topic, modulo division, right? Mod based arithmetic. Good evening, good evening. Hi Jake, how are you? Pawan. So, modulo division. Now, modulo division is also known as mod based arithmetic. So, we'll discuss that in today's session. And why precisely are we adding this topic? Because I think, like in the last session, I talked to you about social intelligence, emotional intelligence, and ethical dilemma. Now, these topics were generally seen for the first time in 2025 SSC selection post examination, also repeated in SSC steno examination. So there was a buzz around these new topics that there is a good probability that they might be asked in SSC regularly now. But it was not seen in SSC CGL 2025 though. Despite that, we are assuming we are having a strong hold that these new things can be introduced now that the topic is, now that the pattern is changing. Okay. So modulo division is one such topic which is a part of that. Now, when we talk of modulo division, mod based arithmetic, okay. So you already have been using modulo division as a calculation tool for your reasoning section. Technically, this complete session which you are going to do today is actually quant based. It's actually a maths based concept. But if you see, nowadays a lot of it is being intersected with the reasoning section. A lot of quant intersects with the not a lot of, but I would say at least 5 to 10% of the quant section is intersecting with the reasoning section. The reason being that the very easy topics which they can't ask there because they want to reserve that place for 25 questions for difficult good questions, they are now bringing them to the reasoning section. So simple question on ages, simple question on your mixture allegation, okay, those basic level arithmetic questions of quant are now also asked in reasoning section, one or two questions here and there. And modulo division is one such method which now we don't learn it quant, but we learn it in reasoning only. Okay, yeah, absolutely fine. So today what we'll do is we'll understand the complete concept of modulo division, and then we'll switch on to some wonderful questions. Okay. So when I divide two numbers, what exactly is modulo division? When I divide two numbers, let's say I'm simply dividing 10 by 5. So I'll write the answer as 2. Correct? I'm dividing 15 by 3. So I'll write the answer as 5. I'm dividing 20 by 3. So I'm writing the answer now as, so now this is confusing for a lot of people. I'll come back to this now. So why is this happening? Because when I divide 10 by 5, so this is how we work. Okay. So this is the 2 which we are writing here. If I divide 15 by 3, so this is the 5 we are writing here. So if I divide 20 by 3, now a lot of people will continue the division. They'll say 6.66, but I don't want that. This is just the answer I'm looking for. Okay. This is how division works normally. You have all seen this as little kids. How does division work? So what do we take out from this? We conclude. Okay. I'm quoting Euclid's here. Euclid's division lemma. Dividend is equal to divisor into quotient plus remainder. You have all learned this as little kids when you first started division. This is precisely it. So here dividend means 10 is equal to divisor into quotient plus remainder. Remainder is 0. This is remainder. Dividend 15 is equal to divisor into quotient plus remainder. Remainder is 0. This is quotient. This is divisor. This is dividend. Similarly, dividend is equal to divisor into quotient, but this time we'll add a remainder 2. Okay. So this is how we will be writing it down. This is how we utilize it. How do we depict it? We depict this division regularly by either this sign or this sign or simply fraction. So if I write 10 divided by 5, or I write 10/5, or I write 10 upon 5. In all these cases, what I mean to say is 2. So what is this? This 2 or this 5 or this 6 is basically the quotient. So what is regular division? Regular division returns the quotient as your answer. Returns the quotient as your answer. Right? Clear? Audio is repeating. That should not be the case. Hello. No, that doesn't seem to be the case here. Have you opened two windows by any chance? Yeah, you can just refresh at one point. This is also visible in YouTube. So if you have opened right now in two windows, you might be hearing an overlap. Okay, if that is the case, just close one window. Now, apart from this, if I divide 10 by 5, but this time I am giving the answer 0. I am dividing 15 by 3, I am giving the answer 0. And I am dividing 20 by 3, and I am giving the answer 2. So what am I doing? Okay, perfect. Good. Thank you guys. So when I'm dividing by 5, 0. So this is the answer I've written here. When I'm dividing by 3, 0. So this is the answer I've written here. When I'm dividing by 3, this is the answer I've written here. This time what am I doing is I'm returning the remainder. Okay. So how do I represent this division? Do I represent it with the same sign? No. So technically we were using this division for normal division. I'll just rotate this completely. So I'll use this sign now. Okay. And this is exactly what is known as modulo division. The moment I utilize the operator of modulo division, I will be able to find the remainder as the answer. So I'm directly now looking for the remainder. I'm not interested to look for the quotient, right? So this is exactly how it works. It will either be depicted by this sign, or we can simply write mod in between. So I can either write 10 mod 5 like this, or 10 mod 5. One and the same thing. Okay. And we call it modulo division. Please don't get confused by the word modulus. I'll explain that also. Modulo division, which returns the remainder as the answer. Now a lot of people get confused by this. Let's say I have minus 20 and I put it in this sign. So I'll get 20 as the return value. You have seen this. All of you might have seen this somewhere or the other. This is known as a modulus operator. Modulus operator, often utilized here. Modulus operator, argument values, right? High level engineering mathematics, we don't need to go there. But the idea here is that this is a different operator. This returns the absolute value of an integer. So no matter whether it is positive or negative inside, you will always get positive as the answer. And if you really want to solve it, if you remove this bracket, so opposite the equal to sign, you will put a plus and minus and you will solve it 2 times to generate 2 different values. Okay. But this is not what we are talking about right now. Modulo division is a division where the remainder is returned as the answer. That's it. Simple division where we find the remainder rather than the quotient. So modulo division, mod based division is different, and this modulus operator is different. Though in logical reasoning, in 2 different topics, you utilize both these operators separately. So you use this operator, the modulus operator, in the topic of clocks, where you find the angle, so that if there is a negative value of the angle, despite that, it will convert into positive and give you the answer. Okay. And whenever you learn it in calendars, so when you divide by 7, you don't go straight division, you do a modulo division to find the remainders, right? The remainders will give you the number of odd days with which you make the calculations pretty easy. So that's the whole idea. This is where you have already been using this in the reasoning section so far. But now, rather than you focusing on the application, we are focusing on direct arithmetic involving the concept of modulo division. Direct arithmetic. Okay. So direct questions will be given that, okay, if I'm putting mod here, how will we solve? How will we get the answer? So now what our main focus point is, we need to understand what are the common properties and some short tricks, and then we'll be ready to solve the questions. That's the whole idea. Okay. So let's start looking at the concept here. So this is the modulo division which I was talking to you about. For example, 17 mod 5. So 17 mod 5, how do we solve this actually? Each time we are not going to solve it like this, no? This is not how we are going to solve it. So in the table of 5, the closest multiple of 5, which is smaller than 17, it is 15. Subtract 15 and 17, you will get 2. So 2 is your answer. Okay. And this is what is happening here. This is the Euclid's division lemma. Okay. Now, what are the common properties? The first property is the commutativity property. Commutativity means if I multiply 2 numbers, let's say I'm multiplying 3 and 4. 3 into 4 is 12. 4 into 3 is also 12. If I'm adding 2 numbers, 8 plus 5, 13. 5 plus 8, 13. That means the order does not matter. That is precisely what is commutativity. But this is only valid for multiplication and addition. Similarly, commutativity is valid here also. A into B mod M. So I'm taking a product of 2 entities and I'm finding their remainder with M. It will be same if I multiply it in the reverse order. B into A mod M is also same. This is also valid for plus also. Okay. So A plus B mod M or B plus A mod M is also equal only. Now addition property. This works like the distributive property. Okay. So A plus B mod M. So we can open it like this. A mod M plus B mod M whole mod M. Okay. That means rather than me finding their sum first, getting a larger value and then finding the remainder, I can find individual remainders and add them. Why this extra mod M in the end? This is just for safety's sake. If at all after finding individual remainders and adding them, if my answer is still greater than M, still greater than the divisor, then I will further find the remainder. Okay, that's the idea here, right? For example, 18 plus 15 mod 7. We can have two approaches here. Either we add both of them, so we get 33. So 33 mod 7. This is what we are looking at. So the closest one is 28. Okay, subtract 28, we'll get 5. This is one approach. The other one is 18 plus 15 mod 7. So you open it one by one. You say 18 mod 7 plus 15 mod 7 whole mod 7. So 18 mod 7, 7 2s are 14 is the closest one. So we have 4 plus 15 mod 7, 7 2s are 14, 1. And 5 mod 7. Anything less than 7, the same remainder will be remaining. Okay, if I have 2 mod 9, so 2 is going to be my answer. Okay, remainders will only come out if the dividend is greater than the divisor. So I can take either of these paths. Now, it was very easy for me to divide 33 and 7. But if these numbers were quite large, it would have been better for me to find individual remainders and go ahead. Remember, both the methods are important for you because it will depend on the question, which property will you choose and when. I'm not going to ask you, you will not have to each time break a larger number into smaller parts because sometimes visualization will be quicker if a larger number is there at stake, right? Now, what about multiplication property? Same like addition, we'll replace it with multiplication. A into B mod M is A mod M into B mod M whole mod M. Let's look at another example for this. So we have 18 into 15 mod 7. So either we can do 270 mod 7. Okay, so how will we solve this? We will divide this. So if we divide this by 7, 7 3s are 21. We have 6, 7 8s are 56. So we are left with how much? 56. 60 minus 56, 4 is the remainder. Okay, this 38 is the quotient, but I'm not interested. 4 is my remainder. Or what I can do is 18 into 15 mod 7. So I'll open it as 18 mod 7 into 15 mod 7 whole mod 7. 18 mod 7 was 4, 15 mod 7 was 1 whole mod 7. So this is again 4 only. Okay. Now power property. Power property is A to the power k mod m. This can become a very large number. So what we do is we find A mod m and we raise it to the power k and further add mod m. Simple example here, 10 power 100 mod 3. Now 10 power 100 mod 3. Are we going to put 100 zeros after 10? No. So what do? We say 10 mod 3 whole power 100 and for the safety sake we add mod 3 here. So 10 mod 3 is how much? 3 3s are 9. So 1 is left. 1 power 100 is 1 only and 1 mod 3 is nothing but 1. Okay. Now these are common properties which are going to enable you to solve questions faster. So rather than each time going with a standard method, a lot of people when they encountered the mod based question for the first time, they were not aware of these properties. So what they simply did was they found out, they solved the LHS first, the value before the mod, solved it, simplified it, got a single number, then actually divided and found the remainder. That was the only choice they had. Okay. So again, this might simplify a lot of it for you. Now let's look at the short tricks. Okay. How can we increase the speed further? So of course, we are going to use these properties. One case is we are breaking down large numbers. So if we have extremely large numbers, we can break them down into shorter products or shorter sums and then add the individual mods which will become faster. For example, in this case, don't go for this, okay? Don't go for the solution. I want to show you something which is a very good trick. If I multiply this, just because it is being divided by 5, this can actually be done very quickly. How? 4 into 7, the unit digit is going to be something ending in 8 mod 5, correct? I don't want to find the answer. Something ending in 8 mod 5. Now, the divisibility of 5 says all the numbers ending in 0 or 5, all of them are divisible by 5. The nearest number, if we go back, will be 5 only, number ending in 5. How will you get to that? By subtracting 3. So what is the remainder? 3. But this is not applicable for all the numbers. It is easy when the divisibility test is something about the last digit. But otherwise, you may not be able to solve it like this. Okay. So how do we generally approach it now? We have two options. Either we multiply the whole thing, which is going to cost us a lot. 200, 500. Okay. It's going to cross 10,000, which is a very heavy value. Or what we do is we simply find out individual mods. So 234 mod 5 into 567 mod 5. Now we'll use the same technique here also. Okay, so 234 mod 5. Even if you don't put this mod 5, is not going to make a difference, because if the number is greater than 5, you further find the remainder, and if it is not, that is your answer. 234 unit digit should have been 0. The closest number which while going back is 0. So 4 is the remainder here. 5, so 2 is the remainder here. 4 2 is 8 mod 5. So now we'll have to use this. 8 mod 5 is how much? 3. So 3 is my answer. Okay, so rather than actually, some people now who did not know, they would have solved this whole thing. That is what we need to avoid. Okay. The second one is using negative remainders. So now come back here, 234 mod 5. What we did is, I told you to go 234 mod 5, you went to 230, right? 5 into 46, correct? But rather, I would want you to go for the next number which is closer, 235, but it is greater than your dividend. So go for 235, subtracting 235, what do you get? -1. This is a negative remainder. This is a negative remainder, and whenever you get a negative remainder, you add it to the divisor to get the final remainder. So final remainder is 4. It will still be the same only. But if you are closer to a number which is coming afterwards, subtract from it directly the negative remainder, add it to your divisor to find the answer very quickly. That way it will help to solve faster. Look at this example, 99 mod 10. Now technically, if I say 99 mod 10, I am looking for 10 9s are 90. Subtract it, you will get 9 as a remainder, which is exactly here. Rather, I can also go for 100. So if I subtract 100 here, I'll get -1. -1 is a negative remainder. -1 plus 10 is 9. So I'll again end up getting 9 only. But make sure when you are going with a negative remainder for faster calculation, you don't forget to add the divisor. Otherwise, you'll end up making an error. Okay, I can use it anywhere. Let's say I want to divide 140 by 12. Now, of course, 12 into 11 is 132. But, you know, remembering something of that sort may be cumbersome sometimes. I remember 12 square is 144. So I'll subtract 144. So I get -4. -4 plus 12 is 8. So the remainder is going to be 8 in this case. This is what we are looking at. Yeah, perfect. No issue. Okay. Got it? So this is how we can use it, negative remainders. And the third concept is cyclicity. This is something which has never been asked in SSC directly. I mean, in the mod section, they have never asked this. Of course, you have been taught remainders in the quant section, so you already know a lot about remainders. But there are different approaches to it. This one is slightly different. Cyclicity. For example, they are asking you find the last digit of 7 power 100. Right? Here, what is the concept behind it? I'm just explaining the concept to you. So, what exactly is happening? Let's say I have a number 2, 4, 9, 8, 7, 6, 3, anything, I mean something of this sort. Let's say, suppose I'm asking you what is the last digit. It is as good as if I take the remainder with 10, because when I divide it with 10, I will have 2, 4, 9, 8, 7, 6, 0. So I'll subtract that, I'll be left with 3 only, no? Cool. So this is what I'm looking at. If somebody is asking me the last digit of a particular number, I'm basically looking at mod 10 of that number. Now look at this very carefully. How does this work? Okay. So I have 7 power 100 mod 10. People will say, oh, you already taught us how to do this. We can do this 7 mod 10 power 100 mod 10. Perfect. But 7 mod 10 is how much? 7 only. So again, you'll end up getting 7 power 100 mod 10. So this is useless now. So if the number here is greater than the divisor, then you can proceed with this method. But if it is smaller than the divisor, you'll have to go for cyclicity. What is cyclicity? We'll divide the powers of 7 1 by 1 by 10. So we'll take 7 power 1 mod 10. What do we get? 7. Now we'll take 7 power 2 mod 10. So how do we solve this? For this 1 7, this remainder was already there. We will add another 7 from here. So this is what we are looking at. 49 mod 10 is 9. Next, we have 7 cube mod 10. One way is we can do 343 mod 10. 3 will be the answer. Or for 7 square, we have this 9 already. For one more 7, we add this 7. So 63 mod 10 again is 3. This will be helpful here. 7 power 4 mod 10. Now you don't have to find the actual power of 4 with 7. You know the 7 cube remainder 3 multiply by 7 mod 10. So 21 mod 10 is 1. You again repeat for 7 power 5. 7 power 5 mod 10 is, so 1 will be coming here. 1 into 7 mod 10 is 7 again. Now this, what exactly this is going on is, this is the cycle. This is being repeated now. Again we'll have 7931. Again we'll have 7931. So what is my repeat block? It looks like 7931. This is a cycle. What is the cycle length? The cycle length is 4. Cycle length is 4. So we'll divide this 4. We'll divide this power here. This power will be divided by the cycle length. Modulo divided by the cycle length. Okay. So what is the cycle length? 4. Power is 100. So 100 modulo 4. What do you get? You get 0. What do I do with this now? Now, there are corresponding remainders always. So, if I get 1 as a remainder, for cycle length 4, I can only get 0, 1, 2 and 3. You remember this? So, here R is less than equal to D. Okay. So, R can be 0, 1, 2, only up to D minus 1. It can never be D. Okay. So, my idea here is for 4, for D4, for divisor 4, the remainders can be 0, 1, 2, 3. For 1 remainder, this will be the answer. For 2 remainder, this will be the answer. For 3 remainder, this will be the answer. For 0 remainder, this will be the answer. So when I am dividing my 100 with 4, modulo dividing, what is the remainder? 0. Remainder 0 coincide with what digit here? 1. So what will be the last digit, the unit digit of 7 power 100 mod 10? It will be 1. It will be 1. This concept is known as cyclicity of remainders. The remainders themselves forming a cycle. Okay. So that is how you approach this question. If at all you come across this, you can use this method, or even if you're comfortable with some other method taught to you in quant, you can do that. Yeah. Absolutely. Not an issue. Okay. Like I told you, this is the concept. I'm teaching you mathematics here. The background here, this is not from SSC exam perspective. From the exam perspective, if you know a better method in quant, I would more than welcome you to solve that. Solve it with that. Okay. So that's it as far as the concept is concerned. Now let's start solving some good questions of mod based arithmetic. I would request all of you to participate and generate answers, give answers in the chat box as much as possible. This is the very first question. Correct answers in the chat box, everyone. Okay, excellent. Now we can use negative remainders here pretty easily. Rather than multiplying the whole thing, what we can do is 12, 145 mod 12. So 144 is the nearest one. So 1 is the remainder here. 288, double of 144. 288 is also divisible by 12. Now this is 287. So minus 1 is the remainder here. Minus 1 plus 12 is 11. And 1 into 11 is 11. So option D is the right answer. Okay. Next. This time the question is not talking about the unit digit. It is a concept of cyclicity with mod 5. So this time this is greater than 5. So we can at least take the first step. 7 power 2023 mod 5. So 7 mod 5 power 2023 mod 5, and that gives us 2 power 2023 mod 5. Correct? Now with 2 we can continue our cyclicity. 2 power 1 mod 5. So remainder is 2. 2 power 2 mod 5. Remainder is 4. 2 power 3 mod 5. They're pretty easy actually. So 3, and 2 power 4 mod 5 is 1. 2 power 5 mod 5, 32 mod 5 is 2. So that means the cycle is again 2, 4, 3, 1. Cycle length is how much? 4. So divide 2023 by 4. 2024 would have been divisible by 4. So minus 1 plus 4. The remainder is 3. And 3 does not coincide. Don't when 3 comes up, don't give this as the answer. It is 1, 2, 3, 0. So for 3 remainder, the corresponding digit is also 3 by chance. So option C is the correct answer. Okay. Next. See, technically in this case, we have two approaches. Okay. Approach number 1 is a longer method. Okay. We know that 2n plus 5 mod 8 is what we need to find out. We know the value of n mod 3. But we'll have to convert this in a way that we get n mod 3, n mod 8. So what do? We open it. By the addition property, we say 2n mod 8 plus 5 mod 8 whole mod 8, right? We can further simplify this 2 into n mod 8. So we can say 2 mod 8 into n mod 8. We are not putting whole mod 8 here, plus 5 mod 8 because we already have 1 mod 8 outside, so not necessary. 2 mod 8 is 2, n mod 8 is 3. Sorry. So this is 6. 6 plus 5 mod 8 is 5. So this is 11 mod 8, which is 3. This is one approach. This is slightly longer. The other thing which you can do here is you can actually find the smallest value of n. So dividend is equal to divisor into quotient plus remainder, correct? Right? From that we can find this out. Now q can have various values. Let's put q equal to 1. We can't put we don't want the quotient to be 0. So we'll put the quotient to be 1 minimum. So when we put the quotient to be 1, n is 11. Straight away substitute this 11 here. So we have 22 plus 5, 27 mod 8, which is nothing but 3. So you can use either of these methods to solve this particular question. Okay, good job guys, very good. Next. Right. One smart chap among us. Okay. The questions can be asked. Why have I written it in two ways? Is because the question can either be asked in a word form like this, or they can ask you like this directly. So they are writing what is the remainder when the product of first 10 prime numbers is divided by 10. So these are the first 10 prime numbers. When are dividing by 10, what is the answer? What is the remainder? See, in this whole thing, we have 1, 2 and 1, 5. That means for sure this is a multiple of 10. So any multiple of 10 when divided by 10, remainder is going to be what? 0. Or if you multiply the whole thing, because of 2 and 5, this is going to end in 0. By mod 10, what is the remainder here? 0 only, last digit. Okay. So this is actually a trick question. A lot of people start finding individual remainders, which is the part where they want to fall you into the trap. Next. Okay. Now again, there are two approaches to this question. Approach number one is like recently I find out the minimum value of A is 9 plus 5, 14. And minimum value of B is 9 plus 4, 13. Minimum values. Okay, I'll just substitute them here. So 14 into 13 square mod 9. So I'll open it as 14 mod 9 into 13 mod 9 whole square mod 9. 14 mod 9 is 5 into 13 mod 9 is 4 square is 16. Now I can further open it again. This can be 5, this can be mod 7. Okay. Or what I can do is I can rather just solve it. 80 mod 9 is 8. 80 mod 9, 9 into 9 is 81. 80 minus 81 is minus 1. Minus 1 plus 9 is 8. We are doing that in their head. So 8 is the answer. This is one approach. Second approach is again like we did in the previous question. Let's solve this and find out A mod 9 and B mod 9 to substitute them. So we'll open that. We'll say A mod 9 into B mod 9 whole square mod 9. Now A mod 9 is how much? 5. B mod 9 is 4. 4 square is 16. And we reach the same position again to find the answer as 8. Choice is yours. Okay. Next. Okay. Now, like I told you when I started teaching you the properties, I had told you, you have to decide when to use the property and when to avoid using the property. In this case, if I use the property, I'll take a longer route, because if I see here 225 plus 100 is not very difficult. 325. 325 mod 4. I know divisibility of 4 should have 24 in the end. This has 25. So what is my remainder? 1. This method will be faster for me. Rather than I can do this, not a problem. 15 mod 4 square plus 10 mod 4 square mod 4. This is also possible, not an issue. 15 mod 4 is how much? 12, 3. 3 square is 9. Plus this is 2 square is 4. 13 mod 4 is 1. Okay. Next. Oh, same question. Next. Just let me modify this question a bit. I want you guys to see this as like this. So if 4 equal to 158 mod k, then k is not equal to which of these four numbers? That means k can have 3 options here as values except for 1. Which is that one option? Oh, it can. This question is slightly. Wait. I want to change this question. Because k not equal to was creating a confusion. So what are we going to do here? We are going to check that if 4 is 158 mod k, that means 158 when divided with k is generating a quotient, okay, and finally is generating a remainder as 4, right? So if I multiply 158 will be equal to kq plus 4, okay. If I subtract this 4 here, kq will be equal to 154. That means your k has to be a multiple, so a factor of 154. K has to be a factor of 154, right? Now, k cannot be 4, k can be 2 and 7, k cannot be 8 also. But if I put 2 here, 158 mod 2 will be 0 because it is divisible by 2, it cannot be 4. So this is also not my answer. Option C, 7 is the only correct possibility. Okay, what you can otherwise do is divide them one by one. Divide it here, you will find the answers. So 158 mod 4, 158 mod 2, 158 mod 7 will give you 4. All right. Next. Now we'll just substitute 22 and 10. That's what we need to do. So 22 mod 10. I'm writing all this down. You don't need to. You can directly write the answers. 22 plus 10. 22 minus 10 minus k. 22 mod 10 is how much? 2. 32 mod 12. So 36, 4, 8. So k will be equal to 6. Okay. Next. Correct. One approach is by the options. It is saying x is between 80 and 90. So the options are already telling me they are all the possible values of x. I can just substitute x one by one and find out the answer. I'll find it out at 82. What is the concept behind this? Concept is 7 equal to x mod 15. That means when I divide x by 15, I get a quotient and I get 7 as a remainder. Correct? That means x is equal to 15q plus 7. Okay. Now I can put q equal to 1. That's very less because my x has to be between 80 and 90. Okay. So q equal to 1, q equal to 2, q equal to 3, equal to 4, q equal to 5. So q equal to 4 will give me x equal to 67. Q equal to 5, this will be 75 plus 7, 82. And q equal to 6 will give me x equal to 97. So there is only one possibility of x being between 80 and 90, which is option x equal to 82. Hence option A is the right answer. This is the concept behind it. You don't have to go by the concept. You have to go by the trick. What is the trick here? Options. Substitute from the options and find the correct answer. Okay. So simply divide 82 and 15 to get the remainder 7, and that will be your correct answer. Okay. Next. This is not mod. Okay. This is percentage. A lot of people use this for the mod sign. The mod sign is this is division. Just this is modulus. And this is percentage. They are three different signs. Don't get confused. A lot of people use percentage because on the keyboard you don't have the mod sign available. Okay. Also, a lot of people make percentage like this. This is not percentage. Percentage is always like this. Anyways. So that is percentage, not mod, is what I want to tell you. Okay, and what about the others? Okay, very good. So 4 into 5 is 20. 20% means 1 by 5. 1 by 5 into 25 into 5, 5 and 5 get cancelled. So this will be left with 25. 12 square minus 11 square. So 12 plus 11, 12 minus 11. 12 minus 11 is 1. 12 plus 11 is 23. 25 mod 23 is how much? 2. Okay. So for the sake of it, if you want me to solve it, I'll write it down for the PDF students. 20%, 25 into 5 mod 12 square minus 11 square. So we can do this as 12 plus 11, 12 minus 11. So this is 20% is 1 by 5. Okay. And this is the last question for the session. Short and brief session for the day. We'll end it after this. Okay, see. 15%. 5% is 1 by 20. 15% is thrice of that. So 3 by 20. 3 by 20 into 40. So this is 2 into 3, 6. Plus 64 and 8, 72. So this is 78 mod. 12 into 9, 108. And this is 4. 112 minus 5, 7. 78 mod 7. 77 is the nearest divisible number. So 1 is my correct answer. Option A. Okay. I have to write this for the sake of it, that we have solved it. Okay. Because there may be students who may not understand what has happened. So yes, that's the end of it. Simple, short, sweet session on mod-based arithmetic. What do you have to do? I have practiced some questions which have not been asked in the exam as yet. Not been asked means even the level of those questions was not there. Mostly simple questions only have been seen, and the frequency has not been very high. We have not seen them in CGL exams yet. We have seen them in your selection post exams, steno exams. So there have been some questions there, right? So this is just a basic practice which you need, and nothing new. Okay, you just need to know the basic rules and you'll be good to go. If at all you come across a question from mod based arithmetic. So that's enough for today. Thank you so much for watching me till here, guys. I hope the session was useful to you and you learned something new. I'll see you around in the next session with a new topic. Till then, you guys take care. Bye bye. Namaskar. Jai Hind. Yeah. Sure. Question 2. I'll do that. Just give me a moment, okay?